Hi friends, welcome to my channel on TS1. Now in this session we are going to discuss about the solution of the moment of inertia of the same T section what I have solved already. We had calculated the center of gravity y bar. We got the y bar value is equal to 87.5 mm. The distance from the datum line AB to the CG of the T section is equal to 87.5 mm from the bottom. If it is from the top, it will be 150 minus this 87.5 mm. Okay. Now, today our aim is to calculate the moment of inertia about x-x axis and y-y axis, ixx and iyy. Right? The moment of inertia of this T section about xx and yy axis. Now, when we consider the moment of inertia about xx axis, see there are two rectangles, rectangle number 1 and rectangle number 2. So being the center of gravity or the common xx axis is not passing through the middle or the center of gravity of any of the rectangles, we have to use the Parallax's theorem that you know. What is Parallax's theorem? An axis parallel to the axis of the rectangle. So here this point represents the center of gravity of this rectangle. Similarly, here this point represents the center of gravity of this rectangle number 2. Whereas this is the xx line passes through, this is the common CG center of gravity of the whole figure. So individually, when we consider the two rectangles 1 and 2, what is the moment of inertia of the first rectangle? IgG. What is it? IgG means the center of gravity of that rectangle about its own CG. The moment of inertia about its own CG. Say IgG1, we can say IgG1 is equal to, you know the relation, B d cubed by 12. B into d cubed by 12 is equal to 100 into 50 cubed divided by 12. Similarly, IgG2 is the moment of inertia of the second rectangle through its own CG. So that is also equal to B d cubed by 12 equal to 50 into 100 cube, 50 into 100 cube by 12. Right? So IgG1 and IgG2, this will be equal to 4.25 into 10 raised to 6 mm raised to 4. So like that, find out IgG1 and IgG2. Now apply the Parallax's theorem for Ixx1 and Ixx2. What is Ixx1? Moment of inertia of the first rectangle about xx axis. The two axes are parallel. This is GG and this is xx. So to find out the moment of inertia of the first rectangle about xx, we use Parallax's theorem. Ixx1 equals IgG1 plus A1 into H1 squared. A1 is the area of that rectangle and H1 is the distance between the two axes GG and XS. Right? So substitute this value, that is IgG1 1.04 into 10 raised to 6 plus A1 100 into 50 into H1. What is H1? H1 is equal to, this is 100 till here 125. This half of this 25. So 125 minus 87.5 y bar. H1 is equal to 125 minus 87.5. Is clear? 125 is the distance from the bottom to the center of the first rectangle minus this y bar, so that you will get this distance. The distance between the two axes. So by substituting these values here, you can find out Ixx1. It will be say 8.07 into 10 raised to 6 mm raised to 4 Ixx. Okay. Similarly, you can find out the moment of inertia of the second rectangle above xx. Ixx2. Ixx2 will be equal to the same Igg2 plus A2, area of the second rectangle, into h2 squared. What is A2? A2 is 50 into 100, right? Igg2 we already calculated here, 4.25 into 10 raised to 6. And what is h2? h2 is the distance between the two axes. The distance between the two axes, that means between xx and gg2, right? Here this is 87.5 and this one 50 mm. So 87.5 minus 50 will give you this distance, that is h2. Substituting that value here, you can find out the moment of inertia of the second rectangle also, that is equal to 11.2 into 10 raised to 6 mm raised to 4, or 1.12 into 10 raised to 7 mm raised to 4. Correct? So we got now Ixx1 and Ixx2 separately. Therefore, total Ixx moment of inertia of the whole section, of the whole T section above xxx will be equal to 19.27, 11.2 and 19.27 into 10 raised to 6 mm raised to 4 is the total moment of inertia about xx axis. So we got the moment of inertia. That is the method by applying parallax theorem. Now, to get Iyy now, see, this is yy. So to get Iyy, being it is symmetrical about yy, the section is symmetrical about yy, no need of taking this parallax theorem. Directly you can find out Iyy1 and Iyy2. What is Iyy1? dv cubed by 12, that is the formula you know, depth into breadth cubed by 12. So that is 50 into 100 cube divided by 12, that is Iy1. 50 into 100 cubed by 12 is equal to say 4.17 into 10 raised to 6 mm raised to 4. Similarly, what is Iyy2? Iyy2 is also equal to dv cubed by 12. What is d here? 100. What is b? That is 50. Q divided by 12 is the moment of inertia about yy axis, right? So that is 1.04 into 10 raised to 6 mm raised to 4. We got it separately both. Therefore, total moment of inertia about yy axis Iyy equal to sum of this equal to 5.21 into 10 raised to 6 mm raised to 4. It's okay. So first you check whether the section is symmetrical about xx or yy. If it is symmetrical about yy, no need of considering the parallax theorem. Directly take the formula dv cubed by 12 and calculate and add together to get the total. Otherwise, if it is unsymmetrical, so in this case about xx, so find out separately Ixx1 and Ixx2 and then add it together. Ixx1 means Igg1 plus A1 h1 square, Ixx2 Igg2 plus A2 h2 square. So that you will get the moment of inertia. So this is the method when any section is given. It may be a channel section or I section or L section. You know what is L section? L section is not symmetrical about xx or yy. So in that case, you have to find out both x bar and y bar to locate the CG. After that only you can find out the moment of inertia. It's okay? Clear? Okay? So today I am winding up the class now. We'll meet you again in the next class. Thank you. Wonderful.